You're welcome to today's episode. We're going to be looking at how to test an electrical motor and do fault finding. Here we have squirrel cage asynchronous electrical motor. If there's a fault with this motor, the motor refuses to run, and then we have to find out why it's not running. There are three different types of tests that we can do. One is to do a visual test. This is a quick test that we can do. We can look to see if there's burns. If there's burns, and we can smell it. If the motor has burned, if the winding has burned, we can smell it. And then we have to do visual observation. We have to look at the cables. We have to look for damage, if there's any damage, if there's any split. And then if we cannot observe, if there's we don't have any problem with this. The next thing to check is to see if it's mechanically held up. Assuming this motor is running a conveyor belt, we have to check to see that nothing is trapped in the rollers of the conveyor. We have to check to see that nothing is wedged in the gearbox, so that the moving conveyor is free of any obstacle that might be wedging it and keeping it from being mechanically trapped. And then we also have to examine the bearing to make sure that the bearing is still all right. But normally the bearing takes time before it seizes up. It gives you signs that it's going bad, so it takes a very long time for bearing to go bad and get the motor stopped mechanically. So if we fail to identify the fault with the visual test, the next thing to do is to isolate. Before we start anything, we have to isolate. Before we start to do any check, we have to isolate the motor, isolate the electrical motor, and make sure that it is safe to work and that the electrical circuit is dead. And the next thing to do is the second test, which is a continuity test. For the continuity test, we're going to need an ohmmeter. We're going to need a multimeter. The multimeter will be set at ohms and at a very low resistance. And then we'll be looking to see low resistance in the windings of the motor. And we have to be connecting the U1 and the U2 and see the resistance between them. And also we have to be doing we have to do V1 and V2, check the resistance between them. We have to check W1 and W2. In order to see these things very well, in order to check these parameters very well, this motor is connected in delta. We have to remove this delta connection so that we can be able to check the windings, individual windings. And we have to do the same for, we have to check if there's an open loop. We'll see that there's a very high resistance of each of the windings. If the resistance reading is very high, we know that there's a problem with the winding of the motor. Or if it's open loop, it's supposed to give us low resistance, around 0.1 ohms. So we can start by doing this. Let us do that. So in order to do the continuity test, we have to remove the configuration. Now we get the ohmmeter. We have to set it at a very low resistance. We have 20 ohms here, 200 ohms. And now we're going to set it at 20 ohms. And then we're going to measure the resistance of, we can do U1 and U2. No, this is U2. So we have 3 ohms between U1 and U2. We have 3 ohms between U1 and U2. Okay, V1 and V2. V1 and V2. We have about 3.5 ohms. W1 and W2 have about 3.5 ohms. So we can see that it's all balanced. So the continuity test has been passed. So the next thing to do now is that we're going to do what this continuity test checks is that to make sure that there's no breakage, and there's no breakage. So now we're going to test to see if there's leakage to earth. In order to check if there's leakage to earth, we must disconnect the motor from we must disconnect the mains wire. So we must disconnect the mains cable so that we do not inject high voltage to our components. But the next thing to do now, we're going to do the final test, which is the insulation test. During the insulation test, we will be looking to inject high voltage. We will be injecting high voltage into the windings of the motor. The high voltage output of the insulation resistance tester will search out and indicate any weakness in the insulation of the windings or cable. So in this case, we're going to do the winding. We're not going to do the cable yet, but we'll also do that for the cable of the motor. But first of all, we're going to disconnect it and do it for the motor. And then we do it for the cable as well to make sure that the insulation material can really withstand the voltage of the voltage. So what we do is that we inject 500 volt AC, and we have to look to see that it returns up to between 1 mega ohm and 2 mega ohm. This is what the reading we're going to get here between. So we can test, we can inject now. We put it to inject 500 volts here. So we're going to inject 500 ohms. When we inject 500 ohms, we expect to get between 1 ohm. Now we're going to inject 500 volt DC. This is a DC voltage. So we're going to inject 500 volts. Once we inject 500 volts, we expect to get returns of between 1 mega ohm or 2 mega ohm. Anything less than 1 mega ohm is a fail. So we can disconnect the cable first. We disconnect the mains cable so that we can test the motor, and then we're going to test it with the earth as well. Well, we can decide to do it like this because already it's disconnected here. The mains is disconnected, so we can check this cable. We can just do it like that to see if there's continuity there between the cables. Make sure that there's no that the insulation is all right, because high voltage and corrosion and can cause the insulation of the motor, the insulation of the cable, and the insulation of the winding to deteriorate. So what we want to do is so if we put it on U2 here, we can test it between that to make sure there's no leakage of earth. We test it between each of the winding and the chassis. So now we put it on with the chassis with the earth, and we inject 500 volts as we've set it here. So if we hold it where it says test, push it, now it's gone, 500 volts gone inside, and we can see that we're having 1 mega ohm here. So this is good. The W2 have passed the insulation test. We do the same for U. Between U2 and chassis, we inject 500 volts, and we have 1 mega ohm return. We check V2. We inject 500 volts, and we have 1 mega ohm returns. Okay, assuming one of the phases, assuming one of the windings is linked to the earth, for example, let us link this one to the earth and see what result we are going to have. Because now we don't have insulation between, this is V1 or V2 with the earth. So let's run it let's inject voltage again in V2 and see what we're going to come up with. So we inject 500 volts on U2 and we can see that now we have 0 mega ohm. This shows that there's no insulation. We can see that it's linked here. So there's no insulation. What if we decide to separate them, but keep them a little bit closer? Separate them, but not touching each other, but keep them close. Keep them close, but not touching each other. And when we inject 500 volts in it, the closer it gets, the lower it gets, the lower the insulation. So now we have, when it's separated, it's 1 mega ohm. But when it's close by, the resistance drops. So once we've tested all this, and if it passed everything, and now we can test the cables. We can do the same test between each of the cable and each other. We do tests between the cables, the wires, the conductors. So we can do a test between V2 and U2, for example. We inject 500 volts. We inject 500 volts between U2 and V2. You see the insulation between them is good. We do the same between V2 and W2. V2 and W2. We see that the insulation is good. The insulation is good, 1 mega ohm. It's high enough. Then final test, we have to do U2 and W2. We inject 500 volts, and we have 1 mega ohm, which is good. So if you've learned anything from this video, please click the thumbs up and subscribe to our channel. Thank you. See you on the next one.